Okay, so the next thing we're going to go into in this lesson is rotating. And I think, these lessons can be a lot of fun, but what can be interesting is sometimes there's some of your students who really do well in math, and you get to some of these transformations and they can have a hard time. So, and I always tell them, this has nothing to do with your intellect. Some people's eyes just see this better than others. And, it's okay if this is something that you don't see as easily, and we show them a few strategies, and usually they get it very quickly, but it's not supernatural for everyone to be able to see um, these rotations sometimes or reflections sometimes, etc. People usually do pretty well with the transformations. So the definition of rotation is to turn, basically. It's the transformation of a plane determined by holding one point, the center, fixed, and rotating the plane about this point by a certain amount in a certain direction. And so when we do these rotations, we're going to either be going clockwise or counterclockwise. I'm going to give you a certain number of degrees. We're only going to do increments of 90, 180, 270, or 360. As we talked about earlier when we were looking at the standards for Texas, and that makes these much easier. Now, what I want you to keep in mind is if this is something that you struggle with, you can always rotate your paper however many degrees the problem tells, and it will show you where that shape should land. And we'll talk about how you can use that to help you out. So note, if the direction of the rotation is not given, a positive measure is considered to take you counterclockwise. So if I tell you we're going to rotate positive 90 degrees, then we're going to be rotating counterclockwise. If I tell you we're going to rotate a negative measure like negative 90, negative 180, etc., that's going to be a clockwise turn. And that's something that some students are not, super familiar with. So a positive measure is going to take us counterclockwise. A negative measure is going to take us clockwise as far as the direction of our rotation. So also property of rotation, a figure and its image are congruent, just like with the translation, because we're not changing the size, we're just changing the position. And so we're going to do this some on dot paper. And then we're also going to consider it with coordinates as well. So we're going to construct a 90-degree rotation of this rectangle ABCT D by around point P. And for this problem, this is point P. We can label, these points A, B, C, and D, which are the four vertices. And we're rotating positive 90 degrees. So what I sometimes do for myself is I kind of draw myself an arrow of, okay, well, that's the direction. I'm going positive 90 degrees. So I'll just draw myself a little arrow and kind of model to myself like I'm going positive 90 degrees, which is what I did here. I just drew a bigger version of it up here. So if you think about, what this will look like, and I'll see if I can rotate this paper. I don't know if it's going to let me go that direction. So it's going in the opposite direction. I was just going to try to, turn it. But when I do the rotating, it's taking me clockwise instead of counterclockwise. But if you want to, you can always take your paper and rotate it in the direction that you're supposed to be going, however many degrees you're supposed to be going. This particular software that I'm using, I'm only allowed to rotate clockwise, and so it's not going to be as easy to show you. So what the easiest way to do, and this really is not a complicated thing, if you think about this segment right here, if we're going to take that and rotate that 90 degrees about point P, then think about if you took this shape and you turned it 90 degrees in the counterclockwise direction, where would it land? And I'm going to erase a little bit around this point just to kind of show you. But what you can say is, okay, this point A right here is 2 units, 2 units in this direction to the right of that point P. So when I rotate that 90 degrees counterclockwise, it's going to land in, 2 and I'm going to call this A prime, it's going to land 2 units up. That's taking this and it's turning that point A, 90 degrees counterclockwise. For D, you could do the same thing. From this point P, it's 1, 2, 3, 4, 5. So we would go up 1, 2, 3, 4, 5, and that would be D prime. These other points, if you think about it, they are just 2 units off. This would be B prime and this would be C prime. And here you would have an identical rectangle, a congruent rectangle to the original, but it's turned 90 degrees about point P. And so that's why we did use point P to do some counting. And you could take your paper after you get that drawn and think about, if I did turn this 90 degrees, if you turn your paper 90 degrees, you should see that that is the direction off of point P where it's going to land. So these really, are not hard at all, but some people at the beginning can have a little bit of a hard time seeing them. Now the next thing we're going to do is we're going to do 2 rotations. First, we're going to find the image of the triangle in a 90-degree counterclockwise rotation about the vertex of the right angle. Then secondly, we're going to find the image of the triangle in a 90 degrees clockwise rotation about the vertex of the right angle. So that's telling me that this is going to be the point of rotation, and we're going to do it 2 different times. On the first one, we're going to go 90 degrees counterclockwise, and on the second one, we're going to do 90 degrees clockwise. So we'll do this, one at a time, and it doesn't really matter which one you use. But on this top one, I'm going to do that one 90 degrees counterclockwise. And again, for myself, kind of I'll have to find those strategies, that help you. So what I prefer to do is I kind of extend this out and I give myself some arrows to work with. And actually, I'm going to do that a lighter color and then come in with a darker color. So let me do this maybe in like a yellow. Okay, so this is my point of rotation. And I'm just going to kind of extend this side out and extend this side out. And the reason I just did that is because I've just drawn for myself. I've just extended out 90 degrees because it's about this right angle. Now what I'm going to do next is I have to consider, where these points are going to land. So, and there's, 3 points. But when you're rotating, if one of the points is the point of rotation, that point right there will stay where it is because you're rotating about that point, about the vertex of the right angle. So that point's not moving. This vertices here and this vertices here is what is moving. Well, if this point here is, 1, 2, 3, 4 units to the right, if I rotate it 90 degrees, it's just going to land 1, 2, 3, 4 units up. And let's go ahead and label these, for sake of it. So we'll say that's A, B, C. This up here would now be B prime. C is 1, 2, 3 units straight up. So if I rotate 90 degrees counterclockwise, that's going to go 1, 2, 3 units to the left. If you take this point and rotate it 90 degrees counterclockwise, that's going to be C prime. And then we have this new triangle that is congruent to the original. It's just taking it and turning it 90 degrees counterclockwise. And let's do that one more time, but now let's do it on this triangle below. And now we're going to go 90 degrees clockwise. So again, I'm going to think about 90 degrees. But now I'm going to draw downward because I'm going 90 degrees counterclockwise. And so you're going to draw or extend those sides into the direction you're going. Here, I was going 90 degrees counterclockwise. This time, I'm going 90 degrees clockwise. So again, I can call this A, B, C. B is 1, 2, 3, 4 units to the right. If we rotate that 90 degrees clockwise, we're going to be going 1, 2, 3, 4 units down, and that's going to be B prime. C is 1, 2, 3 up. So if we rotate this, think about this. If this was extended up and we're going to take this and we're going to rotate it 90 degrees clockwise, it's going to land 1, 2, 3 units to the right. That's going to be C prime. And right here, we have a congruent triangle to the original. And I'm sorry I didn't draw that in well. Y'all are well used to that by now, but that pen is not going straight. So what we have now is we have a triangle congruent to the original. It's just turned 90 degrees clockwise. One thing that I sometimes do with students that have a hard time with this is I will go to the dollar store or Walmart or Target or somewhere, and I will buy those small clear plates. And for students who really can't see this, we will lay them on top of their paper, trace it with an Expo marker, and then have them turn the plate however many degrees it needs to go. And it'll show you exactly where those points will land. So that's a really good activity. And let me see if I can find an online reference for that. Okay, so in a blog I found this, but right here, you can put your clear plate on top of the shape. You can trace it with the Expo marker, and then you can rotate it however many degrees you need to, and it will show you, so like for this one, this, triangle was in quadrant 1. Obviously, the rotation was 90 degrees counterclockwise because they turned the plate and showed that it landed here. But this can be so helpful for students who are really struggling with rotations, and even something that I do with people in the college class if they're having a hard time seeing their rotations. All right, going back to the notes, a half turn is when we rotate 180 degrees. And it really doesn't matter the direction because 180 degrees is half of the, half of a full circle. And so you would get there whether you go clockwise or counterclockwise. So what we're going to do is we're going to plot these points. We're going to consider what would happen if we did a 180 degree turn. And then we're going to talk about a rule that will stand true for all half turns, what we call them, which is a rotation of 180 degrees. So A here is at 1, 0. If we rotate this 180 degrees, took this point and rotated it whether it was clockwise or counterclockwise, either one, this would be where A prime would land, and that is at -1, 0. B is at 0, 2. If I rotated this 180 degrees, either direction, it would be right here. This would be B prime, which is 0, -2. C is -1, 2, 3, up 1, 2, 3, 4. That's C at -3, 4. And think, sometimes this is hard for people to see, but we're fixing to finalize a rule for this. So if I take this and I rotate 180 degrees, where it's going to land is at +3, -4. This would be C prime, which is at +3, -4. And what the rule is if you're turning on a coordinate plane 180 degrees, all you do is change the signs, because that's going to turn whatever your point is 180 degrees. So for AB, where we can't plot that, this is just generalizing the rule, it would be -A, -B. This is such an easy problem to get right on the exam, and it tends to be missed by a lot of students. So make sure for the exam you study the rule for a half turn to get some easy points. The last thing for this video is an identity transformation where you rotate 360 degrees about a point. Obviously, if you rotate any point, figure, or shape 360 degrees about a point, it's going to land right back on top of itself. So, I can just model that with this paper. If I take this paper and I turn it, think about what I just did. I did, 90 degree, -90, -180, -270, -360, and I'm saying negative because I went in that clockwise direction. When I go full 360, I land right back where I was, and that's why it's called the identity transformation, because the rotation puts the figure right back onto itself.